Hello, so today I'm doing a bit more structural engineering on this preschool and pavilion project. So I just need to start developing the steel structure a little bit further. So following on from the previous video, I've moved some of the columns into more rational positions, set out a few more grid lines and things just so I can see how that's all working, lining everything through. One of the key parts of the geometry is actually this grid line 7. So if we go into the section there, so just double click on the head of the section marker, grid line 7, this is actually the low point on the butterfly roof. So we must make sure we've got structure there to support that, because we'll have a series of beams, probably where these grid lines are, that act as purlins to then support the butterfly roof coming down. And this would be, if it was a traditional roof, it would be the ridge. Obviously it's inverted, but we're going to need a steel beam there to pick up the bottom ends of that. So that's kind of like a key part. So actually what I'm going to do is pin that there, and then that's fixed. So if I accidentally click on that, that's not going anywhere. Whereas some of these other ones, whoops, like that, you see, let's just undo that. So we want to make sure that that is fixed in place. So going back to the floor plan now. I've modelled in 203, 203 by 60 UC columns. I haven't done any calculations on this whatsoever, so this is purely based on experience. It's a single-storey building, it's only supporting the roof. That'll probably be man enough to do it. Obviously I will do some calculations and check that, but just for the scheme design at the moment, it's kind of going on engineering judgment a little bit. Like I say, it's just based on my experience, really. Preschool roof, we were using these cellular beams. So that's a typical beam that's being cut in half and then had these holes cut out through the flange, and then, sorry, through the web, not the flange, holes cut out through the web, and then they've been welded back together again, and that reduces weight in the web of the beam. Obviously where most of the bending stress is going to be in the bottom flange. So we don't need the material as much in the web, so we remove it, makes it lighter. It's also quite handy for running services and things through, but on top of that, with this building, I don't know if you noticed actually, when we turn the architectural model back on, we've got these circular porthole windows as a design feature for the children to look through. So actually, having all these round holes and things, it kind of carries on with that theme, having that with the cellular beams, because these will be exposed in the preschool. So we're probably going to do something similar when we come through to here. So actually let's put some of those in now. So the levels, because of the inverted butterfly roof, all these purlins are going to be set at different heights. So for the time being, I think let's go back to the section. So what I did on the preschool is I set in loads of different levels. So I was looking at where these grid lines are and roughly where I would like them to be set underneath to pick up the roof, bearing in mind that the roof thickness, that's not determined yet either, so this is just indicative too. But what I'll do is we'll put in a fresh level. So select one of the existing levels, CS, shortcut for create similar. Just roughly speaking, we're going to go right about there, so level 10. Okay, so now on our ground floor, that was at grid line 8, we go to structure, beam, there's a cellular beam, and we wanted this at level 10. Just run it across, so select the midpoint of your column to there. So that's just saying it's not visible in this view, that's okay. Go back to the section, hey presto, there it is. That's now attached to the level, so once we've done a bit more design work on the actual roof build up, we can move that up and down to suit. So if we need that to be tweaked to pick up the roof better, we can do that. But the beam itself is then locked to the model. So if we go back to here, we can now see, look at that, over there, the beam. So you'll notice actually the column heights aren't set to the right level, so we can select those. Top at the moment is just set to level 3. Find that level 10. There we go. And that's now looking much more how we want it to. And it's really now, it's a case of just going around and carrying out the similar exercise. So I'll be quiet now and just crack on with that for a little bit. So there you go, talking to you guys earlier, and I've forgotten the right level there. So you've got to pay attention, but there you go. Happens to everyone, it's not the end of the world. You can see it straight away, so any mistakes you can just go, right, get rid of that. That's all attached to the right level. So we need an extra column in there. That's going to be too far otherwise, so what I'll do is we'll copy one of these over 12. Just put a beam to... How's that looking? So these were to 12. Top level 12. I've done it again, left it on 11. So we could actually pick new. New work plane 12. Okay. Sketch please open one of the following screens. So we were in the ground floor copy 1. So I've done it. There we go, level 12. Quite low why it's done that. Let's just drag that over. Oh, that's on 11. So we can put those down to 11. So you can see, it's going down to that valley there, and it's starting the slope. Obviously, I haven't set these ones yet, so let's get that done. So, grid line 8. Now we've got ones close by to the right height here, but these are set up with preschool, which might change differently to what we're doing here. So we're going to set up our own ones. One over here, so level 13, one grid line 8. So come down to grid line 8, beam, set it on the right level. There we go, level 13. Go. Good. Right, so that's there. You can grab those, put them on level 13. Gosh. You can see how it's starting to come together quite quickly. Final one on grid line 3. Let's grab that there, level 14. Beam, cellular beam, level. There, right. Okay, so what we're actually going to do now, so That is level 12, so I'm going to grab all of those. These all need to go up to level 12, we know that now. There you are. That's level 11, so let's grab all of those. Is 10. Set all those to 10. 15. So in a more traditional building, this this setting out of levels and things, it's not as complicated as this, because you just have a level for each floor plan effectively. So you set the steelwork per floor. Obviously with this one, with a variable geometry sloped roof like this, it's a little bit more complex. 15. So there we have it. So what I'll need to do now is take all of these beams and carry on along these spans here, and then see how we're looking. Next step, once we've got that, so obviously that's great, we've got beams supporting the roofs. At the moment though, there's nothing to support the building. If we were to push a wind load onto it this way, it would all just go over like a set of dominoes. Or likewise, actually, if we were to push it this way, there's a bit more natural resistance in the connections, but if they're not designed as moment connections, then there's still no lateral stability this way. So I don't actually want moment connections in any of this. I'm going to be doing bracing, similar to what we've got on the preschool, so it's finding some bays where we can put some bracing in that don't affect the windows. And then after that, I'll probably come back to the preschool area, because we saw on the last video that actually some of this bracing does affect the windows, if I show you quickly. So where we've got these large porthole windows, so these beams are, again, just getting steel in the right place rather than actually sizing up. That's way too big, but we will need a beam through there with the current arrangement, and there's a window there, we can't have it. So I need to change that current arrangement and move the bracing around to suit. So let me get back on finishing up the pavilion side, then we'll brace some of this up, and then we'll come back and tidy up the preschool. That's the way I'm going to do these beams now. I'm going to show you a different way of doing it, which sometimes can go wrong. So it's normally better, again, if you've got simple geometry and it's all just per floor, you can go, all right, I'm going to go and do the beams on the first floor now. So we go to first floor and away we go. Because we've got so many different floor plans, might be easier actually just to do this with 3D snapping, which sometimes can go wrong. And you still need to make sure that you've got the right plane that it's associated to. So in actual fact, we'll grab one of these existing ones, do CS again for create similar, and then that should, yeah, it hasn't, okay. Right, so we're still going to need to set the level. So level 12, placement plane, level 12, 3D snapping though, and then you can just grab the node at the end of the column, there and there. Because these are all at the right level now, the tops of columns, we've set all of those, that's all going to come through quite nicely. So now this one, level 11. If you can hear snoring, apologies, that's not me, that's my dog. She's either snoring in here, or we get pigeons and squirrels just outside the office. So sometimes you'll hear her snuffling away at the door, trying to get through the door to chase the squirrels and the pigeons, who I'm sure would love her to come out and play with them. She's only a cockapoo, so nothing too ferocious. Level 10. What I'd like to do in one of the future videos is actually show you exporting all of this and synchronizing it to Tekla Structural Designer, which is the design analysis software that I use. So I do all my modeling in Revit, that's both for the structure and the architecture. But the structural engineering design on more simple projects, sorry, I'm forgetting what I'm doing here, level 13. On more simple projects, I use TED's calculation software, which is really good for putting together a calculation pack of elements. But if you've got a whole structural arrangement like this, it's better to do it in something like TED's, where you can look at, rather than just designing a beam, designing a column, you design the whole structure. So you can look at things like the stability with the overall structure. Good, right. So we have it. Not all of these will end up needing to be cellular beams, because some of the spans are quite short, and they'll probably be hidden. Particularly, so over this side is where we've got the changing rooms, showers and things. We're probably going to have a lower ceiling so that we've got somewhere to put in all the mechanical ventilation, so the extract fans and things like that. So all the services will go in the roof space, which at the moment in the preschool side we don't really have a roof space per se, because it's all exposed structure and then just the solid roof build up. So at the back there's a series of rooms where we'll have a dropped ceiling to get some services in there, and the hope is that we can kind of have sufficient mechanical ventilation in that roof space up this end that you're able to sort of, suck out the hot air from the front end and chuck it all out the back. So we're probably going to do a similar kind of thing where we've got some exposed ceilings in the social space, but then in the team space, in sort of like the wet dirty side of the building, we'll have a lower ceiling with all those extract fans and things to suck out all the wet dirty air and chuck it out the building. So yeah, basically what I'm trying to say, some of these cellular beams, they'll end up just being a typical universal beam. Again, I'm not sizing this, that's probably not the beam it'll be. I'm going to keep it as cellular now, just so I don't think that I've designed that when I haven't. But yeah, it's probably going to end up looking more like that. So let's do some edge beams now. So again, this is where the 3D snapping is really useful, because trying to do this on plan would be a nightmare, to be honest. Where you've got such slight differences in level with such a shallow slope. But with this, Revit doesn't really like sloped steelwork. But this seems to work quite nicely. Just putting it into a 3D view using the 3D snapping. It's not going to be associated to the right levels, that's the only thing. So at the moment, I mean, it says reference level is level 13. I mean, so that's 13 there. So I guess it's picking where the starting node was. So level 10. I'm guessing that would be level 10 then. So it's choosing where we were, where we started. So it's not going to be too far off actually in terms of organising what level it's on. But you'll notice then it's got this end level offset, which if you're going to try and calculate that manually, if you were to put the beam in, I'm going to copy that and take that out so I can just stick it back in again. If you were to put a beam in on plan, it would look like that, and then you'd have to try and work this end level offset out. Which you could always do. It's just a lot easier to just say, right, well, we're connecting to that end of the column there, let's do it 3D snapping. So let's keep working our way around. Okay, so you can see that's starting to take shape now. So let's get some secondary steelwork in here as well. I'm just going to go onto a top view, just make sure, because not all of these are actually. So this is where. So I've set up this view here. Basically, the building's all at a little bit of a funny angle everywhere that you go. So I've actually set one of the views, this one, to the correct orientation, so things are actually square to the screen, which makes things a little bit easier. I just want to check, I don't want to basically have a secondary steelwork beam going off at an angle and then off at another angle. So this one, unfortunately, that's been offset. So I need to have a bit of a think as to what we do about that. But for the most part, we're going to just run the secondary steelwork. Excuse me. These grid lines. Apologies, we've got a newborn in the house, so I'm not getting much sleep. So there will be a little bit of slurping of coffee and yawning in the background. But again, the snoring, that's not me, that's the dog. Yes, hello Tilly. Right, so we're going to have this. I think what I'm going to do, certainly just for now, have that as a regular beam. I'm just going to see how is it going to let me. Oh yeah, is it going to let me go at right angles? Yes, it is. There to there. How's that looking? Has it done it? There we go. So it's actually it's been quite clever there. It's realised what I wanted it to do. So we're putting these secondary steelwork down to this primary steelwork, which is going to kind of be acting a little bit as a transfer beam, picking up that steelwork there and there. Unfortunately, like I say, we've got this offset here just where the kitchen wall is pushed out over. So yeah, I think that works quite nicely. Okay, alright, we'll leave it there for now. And it's going on a little bit this video, so I'll stop there and pick things up a bit later on with you guys when we start putting in some bracing and things like that. Alright, thanks a lot. Cheers for watching. Bye.